Hello everyone. So today we are going to look at 0x41haz binary exploitation challenge. This is a very interesting one, so I thought I'll take this up and show you how I went ahead to solve this. So first thing first, we will download the task files. I have already downloaded it. We will go to download folder and we can see that the file is present there. Now we can try to open this in we can try to check the type of this file with file command. So let's do that. We can see that it suddenly shows unknown architecture arc 0x300. So it's not able to determine the type of the file other than the fact that it's a 64-bit MSB. Where we can go. Okay, so let's copy and paste this file. Let's try to run this. As you can see, we are unable to run this. GDB is unable to identify this file. So let's try to open this in Ghidra. I already have Ghidra open with here. So let's try to open Ghidra and see how the full file looks like there. So let's open this file. Click OK, but as you can see here, it is not allowing me to click on OK, and that is because it doesn't know the language of the file. So it's basically unable to decode the file. But we can check what is the type of the file, right? So if we do strings here and run a strings on this, we can see this is very regular GCC, looks like a regular GCC binary with no differences, right? So GCC binary. So we will just click on this browse button here. On the filter we can just say GCC. Go down to x86 64-bit GCC and select this and click on OK. It's a small binary, so analyze should not take much time. Let's wait for Ghidra to analyze this, and then we can go into functions and see what are the functions we can see. That's because Ghidra was also unable to identify the file correctly. But since the number of functions here are quite less, we can quickly check what is happening, right? So ideally the function will always the program will always start at entry, and in the entry we can see that it is calling a function 101165. Let's go to this function. If we double click on this, this is pretty much a decent C-like function, and we can see here that we okay, so let's first try to run this program so we can get a hang of what is happening. When we run this, we see hey, can you crack me, and it's just asking for a password. We will give some password. It says is it correct? I don't think so, right? So let's now analyze the binary and see are we on the correct place. We want to, and now coming back to here, we can see that it shows that banner that we saw just now, and then it does get us of local 48, which is defined as char of 42 length here. So this is definitely the user entered password, so we can mention it as pass here. The next one, software one, is basically the string version of the length, right? So we can do pass underscore length underscore string, And then we see that the next one, local 10, is nothing but the uh, integer version of the same thing that we have seen just now. So it should be just pass underscore length. So this is our pass length. Now we can see that it is basically checking if the is equal to d, and d is basically nothing but 13, right? So if the string value, if the length is 13, is not 13, then it is saying it is it correct? I don't think so. And this is what we saw just now. Is it correct? I don't think so. So let's try to just do let's try to run this program again and verify that 1 2 3 4 5 6 7 8 9 10. Also we see nope, right? It's not showing. Is it incorrect? Is it correct? It's not showing that. So basically, if the length is 13, then we are going past this loop, and it is not printing this is it correct loop, and then it is going into this while true loop where it does some magic, and then it says put as is it correct one. Now here we can see that we are setting a local c variable, and this local c variable at the end is getting incremented by 1. So this is looking like this is the increment variable, so I can call it inc or I or whatever. Let me call it I. So we are seeing that basically it is looping over this local 1e, basically the address of local 1e. Hex representation of something, right? So we should be quickly able to check what this is. Let's just copy this and go to CyberChef. ASCII. We can do it in Python, we can do it in various ways, but probably CipherChef is one of the fastest way to do this, right? So let's convert this from hex, let's say from hex, and we can get this string. Now in C, if you don't know, probably you already know, but what happens is that local 16 will be stored just after 1e, right? And local 12 will be stored so these will be in memory one after another, and this is what this program is relying on. So if we copy this and paste it after this and copy the last one, which is 4c, then this is the password that we should basically get, right? Now the other thing that we have to take care of here is basically this will be stored in this string. So we have to go here and say reverse. It didn't reverse it the way I wanted it to. Okay, so this is FG. This last one, something is wrong. It looks like. This is FG $52 at 2, and we have to first basically do. So we can do this in bash very quickly. We can just say echo whatever we got, and then we do a tag and cat tag and yeah, we can just do a rev of this, and we will get this string. Similarly, we can do this with the next one. So this we can remove, and this is 40 26 54 70. Something is missing. I missed some part of the copying while copying. Yeah, I 7 3 and I have copied only up to 7. That's why it doesn't look correct. Yeah. So once you have this, then we can actually again take this and go back to this, paste this, and do a reverse of this, and you will get this. Similarly, last one you don't have to reverse because it's already single character, right? So you cannot reverse it anymore. So that's how you can quickly. So yeah, the other option is actually, if we don't want to go through all this, and if we don't want to do all this, Google can always help, and you should not be worrying about whether I should Google or not, right? You should always try to see if you can find a solution in Google. Uh, so if we do a file on this, then right. So let's search for this string and see what this is, and we will just paste it here. Let's see. There's something on pentested blog. Let's go to that. There seems to be few others, but let's see if we can figure this out. So let's search for our string. See this, we are getting the same problem that he is mentioning here. If we are doing unknown arch, we are getting this, and our regular tools are not working here. So we should be able to find a solution for this, and if there is a solution for this here, no, doesn't look like it has a solution. Let's see a few other pages, but this should be something that we should be able to figure out, right? So let's again search for our string. Okay, so this is where he explains it. Basically what they are saying is, in order to alternate the header, you must use hexadecimal editor like hexcurs. The 5th byte defines format. Is LSB1, MSB1, and if we open our program in hexedit, 0x, let's copy it so that we have the original file, and then hexedit of A. We can see that it's not 1, right? So let's change this to 1, and then just it will ask whether I want to save it or not, and then I should be able to do file of A, and it should show me the correct version and everything. Let's see if we can open this again in Ghidra and how this looks like, right? So now that this file should be importable, it should not ask us for any details, and as you can see, Now it has already detected that it is GCC and it has not asked that question to us. We didn't have to manually select it, and we can do an analyze on this. We can color functions, and we should be able to again see the entry function. In the entry we should again see the 1165. If we go to 1165, now again we can see clearly that we have our function here, which we could see earlier, right? So it shows the stack layout here, which is what we were talking about some time back when I was after the another, and hence when it is doing a plus here, it is after 1e is exhausted, it will actually go to 16 and then to 12, and that can be basically seen in the stack layout that is given here. You can see it here, right? Stack minus 12 is 12, 0x16 is 16, and 0x1e is local 1e. So basically it is stored in the reverse fashion, and hence when you are incrementing one by one, it is doing it that way.